The change in position of an object with respect to time at certain instant, at that specific instant, is said to be instantaneous velocity. Equal distance in equal interval of time, such a motion is called as uniform motion. The direction of acceleration is opposite to the direction of the velocity. When this is the case, it is said to be deceleration. Hello everyone, I am Vrinda, Faculty of Physics, Vidhyaashram Pre-University College, Mysuru. So today I am welcoming you all with the session 2 of chapter 3, that is motion in a straight line. So in today's session of ours, we are studying regarding the instantaneous velocity as well as instantaneous speed and accelerations, and along with some graphs, that is position time graph and velocity time graph. So in today's session, that is instantaneous velocity and instantaneous speed, how is it going to be? So instantaneous, so what exactly this instantaneous mean? So instantaneous, it is the one which either it is measured or the one which exists at that particular instant. So the change in position with certain instant of time at the particular point on its path is said to be this instantaneous velocity. Remember students, the change in position with respect to time is velocity. When it comes to instantaneous velocity, it is change in position of an object at certain instant of time is said to be instantaneous velocity. So how can you measure the magnitude of instantaneous velocity? That is, it can be measured in terms of velocity is equal to limit delta t tending to 0 delta x divided by delta t. So what is this delta? Delta is nothing but it represents the change. So it can be given as dx by dt. Even d also represents the change in position with respect to time. So that is all about your instantaneous velocity. So what is this instantaneous speed? Instantaneous speed at an instant, it is equal to the magnitude of the instantaneous velocity. So remember, instantaneous speed, it is always an instant, it is equal to the instantaneous velocity at that instant. So what does that instantaneous speed says? It is instantaneous speed at an instant, it is equal to the magnitude of the instantaneous velocity at certain instant. So this diagram, it represents the instantaneous, the instant, in certain instant what is happening, that term it is representing over here. So at this instant, what is the speed? At that instant, what is the velocity? It is given in this term. Next is we are going to uniform motion and non-uniform motion. So now coming to uniform and non-uniform motion. We had studied regarding motion in our last class. That is, in this chapter we are just concentrating on the rectilinear motion. That is, the motion is straight line. The movement of an object is in a straight line. So under this rectilinear motion, two concepts we are studying, that is, one is uniform motion and another one is non-uniform motion. So what is this uniform as well as non-uniform motion? Uniform motion, that is, the distance travelled is equal. It is 0 to 4, again plus 4, that is 8 meters, again plus 4, it is 12 meters. The object is moving in equal distance at equal interval of time, that is 2 seconds. In 2 seconds, a car is moving from 0 meters to 4 meters. Again in 2 seconds, the car is moving from 4 to 8 meters. Again in 2 seconds, the car is moving from 8 meter to 12 meter. So it sweeps equal distance in equal interval of time. It sweeps equal distance in equal interval of time. Such a motion is called as uniform motion. When it is non-uniform motion, so it is said as non-uniform motion when a car, here the object what we are considering is a car which is moving 0 to 1 meter in 2 seconds. Again in 2 seconds, it's moving from 1 to 10 meter. Again in 2 seconds, it is 10 to 25 meter. So here the distance is not equal. So it is told that object moving along a straight line, it covers unequal distance in equal interval of time. Time is always equal, only the distance varies. So it is that the motion along a straight line, it sweeps unequal distance in equal interval of time. So unequal distance in equal interval of time is said as non-uniform motion. So uniform motion is sweeping equal distance in equal interval of time, that is called as uniform motion, and non-uniform motion is object which is moving in a straight line. It sweeps unequal distance in equal interval of time. That is all about your uniform motion as well as non-uniform motion. So in next slide we have got about acceleration. So what is this acceleration? You move. When you start moving, what do you say? You have got a velocity, that is change in position. The position changes with respect to, that is along with time, your position changes. So when there is change in position, what do you call it as? That is, there is velocity. So there is presence of velocity, right? That is, there is existence of velocity over there. So change in that velocity at certain interval of time, that is termed as acceleration. So change in velocity with respect to time is called as acceleration. There is a change in position of the body with respect to time, that is told as velocity, and when there is change in velocity with respect to time, it is called as acceleration. So average acceleration. So average acceleration, it is rate of change of velocity in certain time interval. So in certain time interval, the change in velocity is said to be average acceleration. So for example, if I consider the change in velocity, the velocity changes, that is V1, velocity of an object is V1 at time t1, and velocity of the same object is v2, that is the final velocity at time t2. Initially it is having v1 velocity at time t1 and final velocity is v2 at time t2. So how do you calculate this average velocity? It is calculated as average. Just I'm writing a short form. Actually you're supposed to write AVERAGE, complete term. Average velocity is equal to, it is v2, that is the final velocity minus initial velocity divided by final time taken minus initial time taken. So there is change in velocity with respect to certain interval of time. So it will be dv by dt. So that is all about your average acceleration. So now average acceleration, so this is all about average acceleration, and acceleration, it is a vector quantity. Acceleration, it is a vector quantity. So what is this vector quantity? Vector quantity is the one which has magnitude, that is the number, value, magnitude as well as direction. So vector quantity is the one which has magnitude as well as direction. So what is the SI unit of acceleration? So velocity. So you have acceleration is equal to change in velocity with respect to time. So when there is change in velocity with respect to time, how can you give the SI unit of a change in velocity? Right? So there is a distance which is covered, the position changes, right? So there is change in position of the body with respect to time. Now what do we do? That is, just I'll write it down here. So you have got acceleration is equal to change in velocity divided by time taken, right? So again, what is that velocity? It is the displacement by time taken. Can I mention my displacement as x? Yes. So displacement is mentioned as x into the time taken. So this is all about the velocity and this is about the time taken. So acceleration is equal to change in velocity by time taken. Have I given the velocity term and time taken? Yes. So which is equal to, what is this x? That is the position, displacement taken by an object in certain interval of time. So there is a length which is been swept. So that length is termed as meters. How do you mention the SI unit of a length? It is meter. And what is the unit of time? It is seconds. So there are t into t, so it is t square, that is s square. So what is the SI unit? It is meter per second square, or you can also write it as meter second minus 2. So this is the SI unit of the acceleration. Why minus 2? Because it is divided by s square. When the denominator term comes to the numerator, the power will become negative of 2 or negative of the square over here. So it is meter per second square. So what is the SI unit of acceleration? It is meter per second square. Then now the dimension of the acceleration. As you all know, there is meter as well as there is s square. So what is this meter all about? It is termed as length. So length, there is one length, and s square, so it is time. Second square, it represents time. So it is t minus 2, which can also be written as ms minus 2, right? So m terms L as well as s is nothing but t minus 2 and m to the power of 0. Here we don't have m mass, m naught L t minus 2, which can also be written as LT minus 2. This can also be the dimension of acceleration. So again, instantaneous acceleration. So the acceleration which occurs at that instant of time is said to be the instantaneous acceleration. How do you calculate the magnitude of the instantaneous acceleration? That is as similar as that you calculate the instantaneous velocity. So it is instantaneous acceleration. The magnitude is calculated as A is equal to limit delta t tending to 0, and here we have delta v by delta t, that is change in velocity with respect to time. When in case of velocity, we had got change in position with respect to time. So here it was delta x divided by delta t. The delta represents the change. So change in velocity divided by change in time, which gives you dv by dt. Okay, this is how you calculate the magnitude of the instantaneous acceleration. So next is all about the types of acceleration. We know acceleration means it is the change in velocity with respect to time, right? So acceleration here, why do we call it as acceleration, and when do we call it as deceleration, and when do we call it as centripetal acceleration? So acceleration, if the direction of acceleration is same as that of the velocity, if the direction of the change in the velocity is in the direction of the velocity itself, then it is said that the magnitude of velocity increases. When the velocity increases, it is said to be acceleration. So the body is said to be accelerated. Okay, even more, that is the velocity of the body increases. The velocity, when the acceleration is applied in the direction of the velocity, it is said that the velocity increases. That means it is undergoing acceleration. When do you call it as deceleration? So if the direction of the acceleration, if the direction of acceleration is opposite to the direction of the velocity, that is, if the direction of acceleration, so if the velocity is in this manner and there is an acceleration which is opposing that velocity, opposing force, when the opposing force is applied, then it is said to be, it is deceleration, and the magnitude of the velocity decreases. The value of the velocity decreases when the deceleration occurs. That is, the direction of acceleration is opposite to the direction of the velocity. When this is the case, it is said to be deceleration. So next is centripetal acceleration. What is this centripetal acceleration? if the direction of acceleration is perpendicular to the direction of velocity. Consider that you are tying a stone to a thread and just rotating it. It is undergoing a circular motion. During a circular motion, the acceleration is perpendicular. The direction of acceleration is perpendicular to the direction of the velocity. It is perpendicular to the direction of velocity in such cases wherein the magnitude of the velocity will remain the same. The magnitude of the velocity remains the same, but the direction of the velocity changes. The direction of the velocity changes in case of a circular path. That is, the direction of acceleration is perpendicular to the direction of velocity, wherein the value, that is the magnitude of the velocity, remains the same, but its direction changes. That is nothing but your centripetal acceleration. So I hope you're clear with what is meant by acceleration and what is that acceleration, deceleration and centripetal acceleration. So how do you take this uniform acceleration as? It is same as that of the uniform motion, whatever we have studied. That is, the change in velocity is equal and at equal interval of time. So uniform acceleration means change of velocity by equal amounts in equal interval of time is said to be this uniform acceleration. So that is all about this uniform acceleration as well as acceleration terms. Now coming to a position time graph, which is very important. So position time graph, if you have this basic, then it is very easy for you to derive the equation of motion which is coming in your next sessions. So what is this position and time graph? It is a graphical representation of an object with respect to position as well as time. Since there are two domains here, that is position as well as time, so we have to consider two axis, that is x-axis as well as y-axis. And you students are very much familiar with the graphical representation wherein you have studied regarding the x-axis as well as y-axis. So since there are two domains, we have got two axes, that is said to be as x-axis as well as y-axis. So let me consider this x-axis, y-axis in this form. So this is my x-axis and this is my y-axis. So here in this case, the position is always, the time is considered in case of this x-axis. So it is t. Time is along x-axis and position is always along y-axis. So it is position along y-axis, arrow mark represent it is along y-axis, and position can be, in short, it can be given as x, and in short this can be given as t. Okay, so your position lies in your y-axis and your time lies in your x-axis. This is all about the position time graph. This is just a skeleton of the position time graph. So now, having this position time graph, the skeleton of position time graph, I will just represent few of the graphs to you and I will just tell you what exactly it suggests, what exactly it depicts. Okay, so that is position time graph. Your one graph tells you that. So this is the diagram of a graph wherein x-axis is all about your time and y-axis is all about your x. So if this is a case, you can clearly tell that it is a position time graph. So what exactly is happening here? That is, you can say that the time keeps on changing. Time is not constant. It doesn't stay still. It keeps on changing. Time keeps on changing. But the position, it can be changed or it can be at the same place. So this is the change in time. So this line represents there is a change in time, but the position of object lies in a same place. So how can you conclude this? That is, you can say that the object is at rest. The object is at rest. That means the position of the object has not changed. The object is at rest in certain interval of time. That is, the time keeps on changing, but the position of the object is only one. So object is at rest. That is all about the first graph what I have represented here. Coming to the second graph, it is a position time graph, and the graphical representation is the line is inclined on the x-axis. So what does this suggest? What does this represent? So it is said that as the time increases, it gives a straight line. It doesn't giving you a curvy line or a crooked line. So it doesn't give you a wavy line as well. It is giving a straight line. So what does this straight line suggest? Straight line which is inclined on the x-axis, that is time t, time axis. So it is said that the object is moving with uniform velocity. That is y velocity. Change in position, this line, okay, and with respect to time, there is a change in position of the object. So when there is change in position of the object with respect to time, what do you call it as? Yes, it is velocity. So on the whole, you can conclude that object is moving with uniform velocity. The object is moving with uniform velocity. So this is for the second graph. So coming to the next, that is, so here again you have got position and time. Position is represented in terms of y-axis and time in terms of x-axis. So how do you have a graph now? The graph is said to be in this manner. So what does it tell? So the velocity of an object increases with certain interval of time. So there is increase in velocity. Here there is increase in the velocity because again change in the position with respect to time, and it is a half of this parabolic curve. So it is just increasing. So it is increasing in the velocity. There is increase in velocity. Again when this is a graph, x-axis it is time, y-axis it is the position. Again it is downward. The curve is represented downward. So what does it suggest? That is the velocity of an object decreases. So the velocity of an object decreases. So you have got to know how do you represent the position time graph when the object is at rest and when the object is at uniform velocity, when the object is having a velocity which is increasing and decreasing velocity. This is how you get the graphical representation, and it is very easy. Represent the things graphically, or by looking at the graphical representation, you can just tell where exactly your object lies. Right? So let us go to the next slide, that is position time graph, a note on position time graph. So what is that? The slope of xt graph, that is x means it is position, t means it is time. So the slope of position time graph at any instant of time can give you the velocity of the body at that instant of time. I've told you the slope of xt. So it is change in position with respect to time. Gives you what? It gives you the velocity. That is what here it is mentioned. That is, it describes the velocity of body at that instant of time. So that is all about your position time graph, which represents the velocity of the body. Now there is something that represents the displacement of the body. So here it is velocity time graph. Again, there are two domains, that is velocity as well as time, and time is always taken in terms of x-axis. So I can replace my x-axis by time, and y is nothing but velocity, which is determined by v. Similarly, it goes on with this graph, velocity and time. Again velocity and time. Again here it is velocity and time. So these are the basic things which you're supposed to understand. You should mention x-axis, y-axis, and what x-axis represent, what y-axis represent. If there is any unit or a value, you can even represent the value beside t as well as beside v. If there is no value, you can just leave it as it is. And these are the basic things which you have to know. For a graphical representation, it is not only the line which is necessary, it is also the terms which you have to mention. So this is all about your velocity time graph. And in velocity time graph, I have got the few graphs as like your position time graph. I'll just represent all those here now. So first of all, if you're having a graph like this, what can you tell? So the time is changing and the velocity is a straight line over here. So what can you tell? So you can tell that the object is in uniform velocity. So you can tell that the object is moving with uniform velocity in case of this velocity time graph. So coming to the next graph, that is here I will just draw. So what can you say that what is happening to the object? You can say that object is moving, the uniformity is seen here, that for each time interval there is equal increase in the velocity. So increase in the velocity, that is change in velocity, is known as acceleration. So you can tell that object is possessing uniform acceleration and it is increasing. So it is acceleration. It is not deceleration, it is acceleration. So coming to the next graph. So what is happening here? So here in this case, your object is present, your object's initial is starting from some value and it is increasing. So you can say that object is starting with initial velocity, wherein in this case object is starting from rest. It is from rest, it is increasing. But here in this case, object is having some initial value over here. It is not starting from the rest. So object starts from initial value and it increases uniformly. So there is uniform increase in the velocity of the object. So when that is the case, again it is said that the object moves with uniform acceleration. Uniform acceleration. So here in this case it is starting from rest, whereas in this case it is starting from some initial value. When you're coming to the other graph, that is x-axis as well as y-axis, wherein time follows the path of x-axis and velocity follows the path of y-axis. When this is a case, and again I'm having a graph wherein, so what does the graph of this suggest? So it tells that the object is moving from some value to downwards, that is the velocity of a body is decreasing. So you can tell that it is having a deceleration, that is negative acceleration. So it is having a negative acceleration. The body is having, the acceleration is decreasing. So coming to the next view of the velocity time graph, wherein y-axis represents your velocity, x-axis represents your time, again y-axis represents velocity, x-axis represents time, again it is velocity as well as time. So what happens in this case? Again you are having few of the graphs, that is so in this case, we can say that the velocity, the change in velocity is increasing. And in this case, the change in velocity is decreasing. So when here the change in velocity is increasing, you can tell that there is increase in acceleration. Acceleration is given as A. And here you can say that it is having decrease in acceleration. The body is thrown upwards, and the body is thrown upwards, it moves under the influence of a gravity, and this graph represents all about the body thrown upwards and moving in the influence of a gravity. So this is all about your velocity time graph. So in the next slide, you have the area under the curve. It gives the displacement of the body during the given time interval. So area under the curve, it gives the displacement. Okay, so here whatever comes under velocity time graph, whatever comes under position time graph determines you the velocity, and whereas whatever comes under the velocity time graph gives you the displacement of a object. So in today's class of ours, we have studied what is meant by instantaneous velocity, instantaneous speed, acceleration and average acceleration, along with position time and velocity time graphs, and you have studied what exactly certain graphs depicts. So let us all meet in the next class with the solving of equation of motions having the same graph of velocity time graph, and until then, have a good day. Thank you.